Well, to make a long story short, so far on the board I had 3 RAM chip failures. Initially I looked at waveforms and things like that and it really wasn't helping any, so I looked at the CPM source code that was published by Osborne Computer Corp, and they put a lot of information in there, and one bit that I was after is to get a splash screen, which was the original failure point for this computer. It had no splash screen, it just garbled text on screen. There's a screen there, somewhere, there. I wanted to know what parts of memory it had to address, read from, write to. So I looked at the source code and found that it had to have been in this bank here. There's 32 RAM chips on this computer, so that's a lot of swapping parts over. So I wanted to narrow it down. So I narrowed it down to this 8 here and started replacing them. And I found that 2 of them were faulty. That one for sure, and one of those 3. And the way I was replacing them was I was just pulling the old one out, putting a new one in, new in inverted commas. And so I don't know which one of these were faulty, because I just kept on going until it started working. So I know that one was faulty because that was the last one before the splash screen came up. I was pretty excited about that. I thought, yep, that's the thing fixed. But no, every time I tried to run software, it would crash. So I knew that there had to be something else wrong with it. So Osborne supply a RAM test utility. I ran that and it pointed me right to that chip there. So that's the 3rd one that was faulty. I know that I had 2 faulty ones here because when I tested all the chips that I'd pulled out and replaced with these new ones, lucky I did it that way, I found that 2 of them didn't work. I just knew one of them was that and one of those other 3 were, I don't know which one. Yeah, so once I got the splash screen up, I was able to attempt to boot from floppy. There's the A drive there, so I'm looking through a viewfinder here. And it didn't work. So I looked in the manual and they said there was a calibration routine, and I'll show this a little bit later, where you use the strobe effect of a fluoro light, 50 Hertz here in Australia, and you just synchronise the strobing effect of the light against a spinning disc with printed lines on the bottom of the thing. I'll show that later. That was pretty ingenious actually how they've done that. But once I tweaked that, it started loading software. Then I thought I was home. But this drive has never worked. That there is the B drive, and I've got analog stage issues there. So currently it looks like it's a CA3054 differential driver or amplifier. There's one that I bought which was faulty as well, so I've got 2 faulty ones, and that is another story in itself because that there has been a real pain, so I'll do something on that in a minute. Okay, there it is. Osborne 1 almost working, does boot, does play games, does load WordStar and things like that. Mine is an 82 model. If we go down to the, sorry about the lighting there, if we go down to the, oh where is it? That's the Z80 clone. It's an NEC device. See there that it's 20th week of 82 that was made. And if I look at other devices, there again, 16th week 82. So I'm pretty sure this is a 1982 machine, even though the board's copyright 1981. I've really got that lighting bad. Does that help? Not much. Yeah, so there we have it. Almost working. Don't know how long it was faulty for. It was advertised as faulty when I got it. I thought, well, the screen's working, so how hard could it be? But so far it's been a bit of a pain, actually. Just a bit more information about these drives, particularly the calibration for the motor speed. There's a potentiometer. If I move over to the one that's working, there's the potentiometer, multi-turn pot there. That controls the motor speed. And to get it correct, they come up with this fantastic idea where if you're in, say, a 50 Hertz AC mains country like Australia, then that inner wheel will look like it's standing still when the drive motor is spinning. So you basically try to get it to boot off anything. I don't even think you need a flop in at the time. And when you tweak the potentiometer, those lines will stay still. When you've got them staying still for your, your frequency, like the inside one for Australia, the outside one for the US, then it's set correctly. In fact, when I was testing the machine trying to boot from the A drive, that had no electronics failure, just a speed failure, and I didn't know that at the time. I sort of just had a look and had a boot disk in it. It was miraculous. I just started tweaking the potentiometer, and as soon as I saw that middle ring look steady, the head started moving and the machine started booting. It was just it was unreal. Okay, but this one here has other problems. As mentioned, I'll just tip it down. The analog stages, I'll get some scope readings to show as well. The analog stages are mainly, if I'll show you on this drive first, you've got the read head there. How about use a pointer? Read head comes into this connector here. Then you've got the CA3054 there, which I believe is what's wrong with my B drive. And you've got another driver there. You've got a transistor amplifier stage here. So it's all differential pair all the way through until it gets sort of shaped by an op amp here, acting as a bit of a comparator, I think. That turns it into a nice sharp, looks like a digital signal at the end of that thing actually. But yeah, so I was getting no waveforms at all on my B drive. I replaced the CA, if I get in there, the CA3054, and it was faulty, the one that I got from eBay. Anyway, they're easy to test because they're quite a simple IC. They've only got 6 transistors in them, and you can measure most junctions from external pins. So I've tried to make my own CA32, half of it anyway. I only need half for read, the other half is used for writing. My problem is I'm not getting enough gain out of this when compared to the working one. The amplitude of all my signals all the way through is about half, and this is where it starts. So yeah, my BC547 differential amplifier CA3054 clone is just not up to scratch, but I'll show you some waveforms on that. But other than that, I think it's close. I've got high confidence that that drive will work again. It's just how reliable will it be after that? These things probably fail all the time. Okay, bye for now. So here's the output of the op amp LM311, which is IC5. The yellow trace up top, that is the bad drive, drive B, and the blue trace down the bottom, that's drive A. And this is just noise from the read head. The drives aren't even spinning or reading anything from disk here, but it doesn't matter. Even if I'm reading, the waveforms will change slightly, but not in amplitude. So here you can see the output, and sorry about that thunder, I've got a rare storm here. You can see that the amplitude there is about half. So on 2 volt scale there, so that top one there, what's that, bit over 2 volts, maybe close to 2.5 volts. Whatever it is, it's not enough to drive the digital circuits, the logic circuits that are after it. There's an exclusive OR gate and there's a flip-flop, and I believe that even though that waveform sort of looks okay, and when I've got it running, I can see the pulses and things for coming from the disc, and I can actually sync on them, and it looks good. It just looks like a miniature version of what comes out of drive A. Sorry, I've just and there's some rain. So that's my problem, and I'm going to put a new CA3054 in there, and fingers crossed that'll be it. Well, that's what I wanted to see all along. That's just the noise from the read heads of the A and B drive, and they're identical. And the problem was, as mentioned last time, we had an issue with this IC here, read head amplifier. But I thought there might have been other gain issues. I thought that when I replaced that with my homemade device, that its gain wasn't high enough. But that wasn't really the problem. The problem was that one of the ICs that are connected to the output of the LM311 was loading down the output of the 311. So after replacing that, it was the 4013 flip-flop device, which is this one here. it all started working. So this final report on fixing this whole thing was 5 ICs dead, plus some faulty ICs from eBay. But proof that it works. Notice I booted off the B drive, and there you go. That's been a long time coming. A lot of lessons learned out of this, particularly on the analog side of these drives. I've never had to fix a floppy drive before in this way, particularly when it's really mostly analog stuff. I know there was a flip-flop in there as well, but most of my effort was put on the analog side. So there you have it. You can see a bit of the work I've had to do there. I did get lazy and do a little bit of repair by replacement, but when I sat down and thought about it, I thought, okay, let's start isolating the output of that LM311, because I did replace that thinking it was faulty as well, and it was becoming pretty obvious that something was loading down the output of that, and it ended up being one of the 2 ICs connected, the flip-flop. There you go. Done. I can't wait to put this back together and not have to work on it again.